Welcome back to another edition of your geometry notes. Tonight's notes are going to focus on parallel lines and proportional parts. The first thing we're going to talk about is the side splitters theorem. So if we have a triangle where a line cuts through it and is parallel to any one of the sides of the triangle, then it splits the other two sides proportionally. So it's a lot easier to think about when you can see a picture of it. So we have a line here, it's parallel to this side of the triangle, so it cuts the other two sides into proportional parts. See that? Conversely, we could also think about it this way. If a triangle contains a line that has split two sides proportionally, then the line has to be parallel to the third line. So we'll see some problems where it'll ask us to prove whether or not the two lines are parallel based on the measurements of our two sides. And if they're proportional, then it means that the lines are parallel. And if they're not proportional, then it means the lines are not parallel. Additionally, we can see this this kind of idea at work even when we're not inside a triangle. If we have multiple parallel lines cut by different transversals, then the pieces in between our parallel lines are also proportional as long as the lines are parallel. Again, a concept that's much easier to see in a picture than it is to explain verbally. And along those same lines, if we have a similar scenario and the two pieces are congruent to each other, then another transversal will also create two congruent pieces. So AB will be congruent to A will be congruent to B, and E would be congruent to F, for example. Okay, so the last segment we're going to talk about today is specifically a mid-segment. It looks like something that could be applied to the side splitter theorem. It's a line that bisects any two sides of a triangle, or a line that bisects two sides of a triangle or non-parallel sides of a trapezoid. So a mid-segment in a triangle is something that cuts these two sides in half. It's a line segment that connects the midpoints of two sides of our triangle, or it's a line that connects the midpoints of the two non-parallel sides of a trapezoid. So we could have a mid-segment in a triangle or a trapezoid. The key term is that mid-segments are always parallel to the base of either your triangle or your trapezoids. Okay. If you have a mid-segment in a triangle, the mid-segment of the triangle is always half the length of the base. So let's say this base right here is 20. That means the mid-segment would have to be half that, or 10. Conversely, we could think about that as, let's say the mid-segment were 8, then that means we know that this length of the triangle would have to be 16, or 2 times as big. In this case, the mid-segment of a trapezoid is always the average of the two bases. So we'd have to find the length of this guy, the length of this guy, add them up, and then divide by 2. Or you can think of the mid-segment as being exactly the medium length between the top two sides. So for example, let's say they tell you that the mid-segment is 10, and they tell you that the bottom base or the longer base is 15. Because 15 has to be exactly the same measurement away from 10 as the lower base, then I know that this segment would have to be 5, because 5 is the same distance away from 10 as 15. And we will talk about that much more in the next class as well. So if anything was confusing, put a question mark or highlight or something, and then bring it up in class, and we can certainly go over it as well as look at problems that involve it. Have a great weekend. See you guys on Monday or Tuesday. Bye-bye.